All right, folks, let's take a look at some examples. In example number 1, we're going to solve the quadratic equation below here using the quadratic formula. So we actually already took a look at this equation. We had done it in the first video, and we had used completing the square. Now we're going to use the quadratic formula, and we're going to cut to the chase. So the first thing that we want to do in any one of these situations is put the equation into standard form. Ax squared plus bx plus c equals 0. I basically get 0 alone on one side. Now that's already done here. This is done here already. The second thing that we want to do is identify the coefficients in the proper order, a, b, and c. And so a is the coefficient on x squared, b is the coefficient on x, and c is the constant term. And we have to include the signs with them. So in this particular case, we have a is equal to positive 1, as there is a phantom 1 there, right? And b is positive 4, or just 4. And c is positive 5. And the reason I'm writing positive 5 there and positive 4 and positive 1 is because I want to make sure that when those numbers turn out to be negative, you're actually taking the negative sign with them. Yeah? Okay. So, step number 3. Write the quadratic formula. And I would suggest you write this down generically every time you're going to use it. And then substitute A, B, and C into the form. So that would look like this. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And then we would plug those values in. This is, let's see, b is 4, so this is the negative of 4, plus or minus the square root of 4, parentheses, squared, minus 4 times 1 times 5. And that entire expression, not just part of it, but the entire expression, divided by 2 times a, which is 1. And if we simplify this, we get negative 4 plus or minus the square root of 16 minus 20 divided by 2. And if we simplify that a little bit, we get negative 4 plus or minus the square root of negative 4 over 2. Now, gone are the days where you can say, oh, I can't take the square root of a negative number. That's not true anymore. This is plus or minus the square root of negative 1 times the square root of 4 over 2, which is negative 4 plus or minus 2i over 2. And we can break that up into two fractions. This is negative 4 over 2 plus 2i over 2, which is negative 2. Whoops, I forgot my plus or minus I. So there's two answers here. And x squared plus 4x plus 5 equals 0 if x equals negative 2 plus or minus I. And those are actually the same answers that we had got previously, if you guys recall from the first video. I hope. Let's double check. Yikes. Oh, there it is. Negative 2 plus or minus I. Psh, nailed it. Without all that muss and fuss about completing the square. So let's try another example, folks. Example number 2. How is this example any different than the one that we had just done? Well, for a couple of reasons here, this example is different. Solve using the quadratic formula. So step number 1 here, we need to put this in standard form. So that's not done here. That's the first way that this is different. You can't call out what a, b, and c are until you have it in the form ax squared plus bx plus c equals 0. Now, there's two ways that you could do this. Easily, you could subtract 1 from the right side. Or you could subtract everybody on the left side over to the right and make this 0 is equal to negative 3x squared minus 4x plus 1. However, while you can actually use either one here, it won't matter. But I prefer this one because it has that leading coefficient that's positive, and that makes things nice. So we have our choice here. I can do them both for you. You're going to see that we're going to get both answers. But another way that this is different is identifying our A, B, and C, where here A is 3, B is 4, and C is negative 1. So that's important. We now have negative coefficients, so make sure that those plus minus signs go along for the ride. And I'll do this other one in red alternately. Or A equals negative 3, B equals negative 4, and C equals positive 1. Now, shouldn't that give us different answers? Well, let's find out. For step number 3, we're going to state the quadratic formula x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And the same thing will be true on the other side here. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. And we'll plug numbers in where they go. Careful now. X is equal to the negative of 4 plus or minus the square root of 4 squared minus 4 times 3 times negative 1, all divided by 2 times 3. Whereas on the other side here, we have x is equal to the negative of negative 4 plus or minus the square root of the quantity negative 4 squared minus 4 times a times c, all divided by 2 times a. So on the left, when we simplify this, we get negative 4 plus or minus the square root of 16. Now, always watch your negative signs here, folks. This can get real bad if you're not careful here. This is plus 12 divided by 6. And on the other side here, we have x is equal to positive 4 plus or minus the square root of 16 plus 12 over negative 6. So at least the square root is exactly the same. Oops. On the left side, we have x is equal to negative 4 plus or minus the square root of 28 over 6. On the right side, we have x is equal to positive 4 plus or minus the square root of 28 over negative 6. And if we simplify the square root of 28, by the way, the square root of 28 is the square root of 4 times the square root of 7, which is 2 root 7. So the left side can be rewritten as negative 4 plus or minus 2 root 7 over 6. And the right side can be rewritten as positive 4 plus or minus 2 root 7 over negative 6. And in both cases, I can break these up into two fractions. This is negative 4 over 6 plus or minus 2 root 7 over 6. And I'm just going to keep simplifying this side. This is negative 2/3 plus or minus the square root of 7 over 3, which is two answers. Negative 2 plus the square root of 7 over 3, and negative 2 minus the square root of 7 over 3. And those are our two answers. On the other side over here, if I break this up into two fractions, I get 4 over negative 6 plus or minus 2 root 7 over negative 6, which is negative 2/3. That's the same. Plus or minus square root of 7 over negative 3. Now, if I rewrite that as two different answers, one of them is negative 2 over 3 plus the square root of 7 over negative 3, and the other one is negative 2 over 3 minus the square root of 7 over negative 3. And if I bring this negative sign out front here and bring this negative sign out in front here, I'll end up flipping signs, and this will be negative 2/3 minus the square root of 7 over 3 and negative 2/3 plus the square root of 7 over 3, which is exactly the same set of answers. And I'll just write them over a common denominator. This is negative 2 minus the square root of 7 over 3 and negative 2 plus the square root of 7 over 3. This is the same set. So it doesn't matter which way you do it, and since it doesn't matter which way you do it in terms of right side or left side, I always suggest doing it so that your x squared term is positive, but you can do it any way you like. It's no big deal.